Welcome to the Glad Labs podcast. Today's episode, From Proof of Concept to Production, the art of building reliable RAG pipelines. Let's talk about the moment every developer hits when working with generative AI. It starts with that spark of excitement, typing a simple prompt, getting a coherent response, feeling like you've unlocked some kind of magic. You ask a question, and the large language model, or LLM, gives you an answer that seems thoughtful. It feels amazing, but then reality sets in. You try to apply this to your company's actual data. You want the model to answer questions based on your internal documents, your code bases, or your customer support logs. You quickly realize the LLM doesn't inherently know your data. It only knows what it was trained on. This is where Retrieval Augmented Generation, or RAG, comes in. It promises to connect the general knowledge of a pre-trained model with your organization's specific private information. But building a RAG pipeline isn't just about writing code. It's an engineering challenge. Moving from a working prototype to something ready for production requires a big shift in thinking. You stop asking, can it work? And start asking, can it work reliably at scale and safely? Building a production-ready RAG system is what turns a simple experiment on a developer's laptop into a tool that helps thousands of employees work faster. The biggest mistake developers make is confusing a proof of concept or proof of concept with a real production system. In a proof of concept, you often use clean, structured data, perfectly formatted text files with clear headers. You get great accuracy and declare success. But in the real world, data is messy. It lives in PDFs, scanned images, complex web pages, and unstructured emails. When you try to feed this into a RAG pipeline, the first big hurdle isn't the AI model. It's the data pre-processing. To build a robust system, you need to master the ingestion layer. It's not just about dumping text into a vector database. Production data is rarely clean. You often face garbage in, garbage out situations where the system retrieves a paragraph with the right keyword, but the context is completely off. This usually happens because of poor chunking. Chunking is the process of splitting large documents into smaller, manageable pieces of text. If chunks are too small, they lack context. If they're too large, they might exceed the model's capacity or make the information less relevant. Good RAG pipelines use smart chunking strategies. This might mean breaking text down by paragraphs, then sentences, and finally by characters. It also means adding metadata. When you store a chunk, you need to store where it came from, like user manual version 2.pdf, when it was last updated, and what category it belongs to. Another hidden problem is the context window. When a user asks a question, the system retrieves relevant documents and sends them to the LLM along with the query. The model needs to read that context to form an answer. If the retrieved documents are too long, or if the system pulls too many, the context window fills up. The LLM might then make things up, inventing information to fill gaps, or it might ignore the most relevant parts because they got pushed out of the active window. Production systems need to use retrieval, filtering, and chunk pruning. This ensures only the most relevant and concise information reaches the LLM. This is where the real engineering work of RAG separates itself from a theory. If ingestion is the heart of a RAG system, the vector database is the memory. Without a fast, reliable vector database, your retrieval will be slow and your answers inaccurate. Many developers start with a simple vector database for a prototype. But as data grows, those choices become bottlenecks. Production RAG needs a deep understanding of how these databases work and how to optimize them. Pure vector search relies on semantic similarity, understanding the meaning of text. If someone asks how to reset the password, semantic search might find a document about account recovery. That's usually okay. But sometimes, exact keyword matching is better. For example, if someone asks for a specific software patch version, semantic search might pull a general help article instead of the exact document with a number. Production systems need hybrid search. This combines vector search for meaning with keyword search for exact matches. By blending these, you get much better retrieval accuracy, especially for technical queries or questions with specific terms. Beyond search quality, the database must handle the load. In production, you can't afford database timeouts. You need to think about indexing strategies like HNSW, which balances speed and accuracy. You also need to consider persistence. Vector databases often keep embeddings in memory for speed, but they must save that data to disk. When the system restarts, it needs to reload quickly. As your data grows from thousands to millions of documents, you must keep query latency low. The database architecture matters. Some are built for fast data ingestion, others for ultra-fast queries. Choosing the wrong one can mean a system that updates slowly but answers quickly, or the opposite. In traditional software, success is clear. A web server responds under 200 milliseconds. An API returns a 200 OK. In RAG, success is a spectrum of quality and reliability. Many developers fall for subjective evaluation. They test it themselves, and since answers seem reasonable, they think it's ready. But subjective testing isn't enough for production. You need automated evaluation frameworks. These tools use LLMs to grade your RAG system's outputs. For instance, they take a query, the retrieve context, and the answer, then ask an LLM, did this answer accurately use the provided context? They also check for hallucinations or inappropriate content. This lets you run thousands of tests overnight. You simulate user queries and get a clear score on how well the system retrieves information and how faithfully it answers. This data is crucial for debugging. If scores drop, you know exactly where the pipeline is failing. Automation is powerful, but it doesn't replace human expertise. Production systems need a human in the loop. This means every answer generated has a way for a human expert to review, correct, or flag it. This feedback loop is vital for continuous improvement. As the model answers more questions, it learns from human corrections. Over time, this data can refine the retrieval system or build a custom knowledge base that matches your organization's specific language. Finally, success is measured by consistency. You need a golden set of test queries, questions where you know the exact answer. Run these through your RAG system weekly. If accuracy drops below a set threshold, it triggers an alert for the engineering team. This creates a safety net. It ensures new features or model updates don't accidentally lower quality. It turns RAG from a black box into a transparent, measurable system. There's also an economic reality often overlooked. Every interaction with an LLM costs money. Every token generated uses compute resources. In production, users expect instant answers. They don't want to wait 10 seconds. But high-quality, context-aware answers often require multiple steps. Retrieving context, embedding the query, generating the answer, and sometimes refining it. To manage cost and speed, production RAG systems need smart caching. If a user asks the same question twice, the system shouldn't reprocess everything. It should return the cached answer. You can cache the results of vector searches. For repeated queries, the system gives the cached context and answer immediately. This slashes latency and cost. But caching needs careful management. Balance cache hits with data freshness. Don't answer a question about a policy updated yesterday with an answer from 3 months ago. Another key point is token optimization. The context window is limited and tokens cost money. You must be ruthless in trimming irrelevant parts of retrieved documents before sending them to the LLM. Also, consider using smaller, more efficient models for retrieval and a more powerful model for generation. This two-stage approach saves significant resources while keeping quality high. Treating RAG as a resource-intensive service and optimizing for both cost and speed ensures the application stays sustainable long-term. It turns AI from a fancy experiment into a practical business tool. Building a production-ready RAG pipeline is a journey requiring patience, engineering discipline, and constant iteration. It's easy to make a prototype that works for a few test cases, but hard to build a system that works for thousands of users daily. The key points are clear. Start with high-quality data ingestion. Choose the right infrastructure for your needs. Implement rigorous evaluation and manage costs. It's complex, but the payoff is huge. By moving past the magic of the model and focusing on the mechanics of the pipeline, you build AI applications that are not just impressive, but also reliable, safe, and genuinely valuable. The future of enterprise intelligence lies in these systems. Are you ready to build that kind of system? Thanks for listening to the Glad Labs podcast. Visit gladlabs.io for more episodes, articles, and insights. See you next time.